So let's look at question number 11 on the higher unit 1 specimen 2 NAB. So on a particular day at 9 o'clock, a doctor injects the first dose of 120 milligrams of medicine into the patient's bloodstream. The doctor then continues to administer the medicine in this way at 9 o'clock each day. The doctor knows at the end of the 24-hour period after an injection, the amount of medicine in the bloodstream will only be 30% of what it was at the start. Notice it's not reducing by 30%, it will actually only be 30% of what it was at the start. So it says set up a recurrence relation which shows the amount of medicine in the bloodstream immediately after the injection. Okay, so let's do that. So we know that the recurrence relation should start U of n plus 1 equals a multiplier U of n and then an add or a subtract at the end in this case. So the multiplier in this is 30%, so we write that as 0.3. So we'll go down to answer that here. So 0.3 U of n, and we also know that the person is getting 120 milligrams of medicine each day at 9 o'clock. So on your recurrence relation, you want to add on 120. Just a point to note, the initial value here is the 120 in the first dose there. Okay, let's continue to read the question. The patient will overdose if the amount of medicine in their bloodstream exceeds 230 milligrams. In the long term, if a patient continues with this treatment, is there a danger they will overdose? So this is a limit question. We need to work out what's going to happen eventually once we go round and round the recurrence relation. What limit is it going to go to? Now, we should know that it is going to have a limit because this multiplier is between -1 and 1. So that's the first thing you want to write down. Since -1 is less than 0.3 is less than 1, a limit exists. The next thing I would write down is I would say that because a limit exists, the value going into the recurrence relation and the value coming out at this limit will be exactly the same, which we're going to call L. So let U of n equal U of n plus 1 be L. We're going to put an L in here, and we're going to put an L in here. That's going to look like this, and now we just have an equation with L, and we need to try and sort it out and solve it. So firstly here, take away 0.3 from both sides, so that's 1L, take away 0.3, it's going to give you 0.7L, and that comes to 120. Then divide through by 0.7, so 120 divided by 0.7, and that gives us 171.4 milligrams. So the usual statement applies here. Eventually, the amount of medicine in his bloodstream, that's just related to the question, and then settles at 171.4. So it says here, is there a danger they will overdose? Well, we're well below 230 milligrams, so hence the patient is not in danger. Make sure you write 171.4 is less than 230. Okay, question 12. On to differentiation now. So given f of x is all this, we've got to find f dashed x. So the first thing to do here is to sort it out so that we can actually differentiate it. And that means take any powers up to the top and change any roots into fractions. So that there is 5x to the power of a half, and take the x squared up to be x to the minus 2. That's going to give us this. Notice we've not differentiated here yet. We're now going to differentiate, multiply down by a half to get 5 over 2, and then reduce a half by 1, so that'll be negative a half. Multiply down with negative 2, be careful, that gives you a plus 6, and then reduce this by 1 to give you negative 3. Now we can take this further. I've not done it here because this is all you need to do in the NAB. Okay, lastly in this lesson, let's look at question 13. A rugby player throws a football vertically upwards. The height of the ball t seconds after it's thrown can be represented by this formula here. Now the velocity of the ball at time t is given by v equals dh by dt, i.e. the derivative. If we differentiate that, we get the velocity. We've got to find the velocity of the ball after 3 seconds. So the first thing you want to do here is actually differentiate it to get dh by dt. So 20t differentiates to 20, multiply down by the power, so take away 6t to the power 1. Now we want to find the velocity after 3 seconds, so the time becomes 3, so we'll sub in 3 here and write when t equals 3, and that's going to become 18, so 20 take away 18 equals 2. Now, sentence to finish, the velocity of the ball after 3 seconds is 2 meters per second.